let us study non-ideal solution under the chapter solution. A non-ideal solution is one that does not obey Raoult's law over the entire range of concentration. That means the solution which is not obeying Raoult's law. There are two ways it is possible. One is called positive deviation from Raoult's law, another is called negative deviation from Raoult's law. Now suppose in a solution of a binary solution, two components are there. The vapors from both the components, say those are liquid components, vapors are coming on the surface of the liquid mixture. Now if it is there that the type A particles having interaction between them and type B particles having interaction between them. If after mixing of component A and B, the interaction, intermolecular interaction, hydrogen bond, whatever, if the interaction between type A and type B particle is becoming less than the original, AA and BB interaction, then what will happen? More vapors will come on the surface than expected, and that is called positive deviation from Raoult's law. That is, the vapor pressure will be more than the expected value. For example, say ethanol and acetone. In ethanol molecule there is intermolecular hydrogen bond, but when acetone is mixed in ethanol, the hydrogen bond becomes weaker and more number of ethanol molecules as well as acetone molecules comes on the surface and the vapor pressure becomes more than expected. Now here it is negative deviation. What happens? For example, say acetone and chloroform. When they are mixed, there will be formation of intermolecular hydrogen bond between acetone molecule and the chloroform molecule. That means after mixing of the two components, the attraction force between A and B kind of particles, A and B kind of particles become more than original AA and BB interactions. Therefore, less number of vapor molecules will come from the liquid mixture and the vapor pressure will be less than expected. Now let us find the graphical representation of these two situations, positive deviation and negative deviation. Here is a graph for two component liquid mixture vapor pressure graph. Here vapor pressure is plotted against mole fraction. So here chi1 equals to 1 means component 1 is there. Its vapor pressure, pure component vapor pressure is P10, and that of mole fraction of chi2 is gradually increasing, and at this point the mole fraction of component 1 is 0 and that of component 2 is maximum. Therefore at this point the vapor pressure for component 2 is P20. It is that of the pure component. Now we can follow that when these two components, two component liquid 1 and 2 were mixed, then the vapor pressure is becoming more in each case. That means if we draw a line from here, if we take rather a composition here, certain composition of component 1, certain mole fraction of component 1 and certain mole fraction of component 2, then say this is the line for component 2. Now expected value is this one, that is P1, but due to positive deviation the value is coming here, and for component 1 the expected value is here, it is cutting here, but actually it is coming here due to positive deviation, and therefore when we add these two values of say P2 and that of P1, then the total pressure according to Dalton's law becoming P1 plus P2, that also becoming more than the expected value. This is the value coming and this was the expected value. So this is the graphical representation of deviation from Raoult's law, positive deviation from Raoult's law. We can take another example, carbon disulfide and acetone. When these two liquids are mixed, then the vapor pressure becomes more than the expected value. And here comes the case of negative deviation. So you can follow, it is similar graph like this, but in each case the expected value is becoming the red lines. The expected values are less, the obtained value are less than the expected value. So here also if we take a composition, the expected value was this for P2, but actual value is coming here. So in case of the component 1, the expected value is here, but the actual value is coming here. So the total pressure P total, that is also more than the expected value. Here comes, less than the expected value. So it was actually expected value is this, but the actual value is P total is this one. Now the example of negative deviation is phenol and aniline. Another example. Here then let us discuss about azeotrope mixture. What is the azeotrope mixture? We can explain this as for a binary mixture, means two component liquids mixture, there is a situation may come when the composition of the two liquids in the liquid phase as well as in the vapor phase becomes equal. So that mixture is having same composition in the two phases and that mixture boils at a constant temperature. So we can define azeotrope mixture is a binary mixture having same composition in liquid and vapor phase and boil at a constant temperature. Okay. Now there comes positive deviation. In case of positive deviation, we find that the boiling point becomes minimum. The azeotrope is called minimum boiling azeotrope. Then that is the solution boils at a lower temperature than the expected value. What happens due to positive deviation? The vapor pressure becomes more than expected. So when the vapor pressure is more, the boiling point becomes less than the expected value. And in case of negative deviation, what happens? The vapor pressure here becomes less than the expected value. So therefore, since due to intermolecular attraction is increasing here, so the vapor pressure on the surface becomes less than the expected value, and thus due to lesser vapor pressure the solution mixture boils at a more temperature than expected value, and it is called maximum boiling azeotrope. That is, positive deviation means minimum boiling azeotrope and maximum negative deviation meaning maximum boiling azeotrope. So here are examples. Ethanol and H2O gives minimum boiling azeotrope. Nitric acid and water gives maximum boiling azeotrope. Now what happens during azeotropic condition? Suppose this mixture ethanol and water are 95% ethanol when it is there, in this mixture. What happens if we want to separate ethanol from water by fractional distillation? It is not possible, as because both the vapor phase composition and the liquid phase composition becomes equal. So that is the thing happens in case of azeotrope mixture.